Hello, this is another video for the Semester 2 review packet. It focuses on the exponential function section. This goes with questions 20 through 24. Alright, question 20 says, for each geometric sequence, state the common multiplier, state the next two terms, and write an equation. So remember, a geometric sequence is a type of exponential function. Geometric sequences are when we are multiplying by a constant. So the first thing it asks for is for us to state the common multiplier. So just what are we multiplying by each time? So if I'm looking at A here, I go from 1.5 to negative 3 to 6 to negative 12. I am multiplying by a negative 2. Part B asks for me to state the next two terms. So if I did negative 12 times negative 2, I'd get 24, and then multiply that by negative 2, and I get negative 48. Those would be my next two terms. C is an equation, so I put the equation up here. A sub n is equal to a sub 1 times r to the n minus 1. So remember, a sub 1 is the first term in the sequence, and this is telling us that it starts with the 0th term. So if 1.5 is the 0 term, then, like in this example, negative 3 must be the first term. So I would have a sub n is equal to negative 3. R is my common multiplier or common ratio. It's just what are we multiplying by every time. Here that is a negative 2. And that's to the n minus 1 power. Alright, let's look at B. I can see that my numbers are getting smaller, so I have to be multiplying by a fraction or a decimal. I know to get from 100 to 20, I can multiply it by 1/5. Or if you like a decimal, you can do 0.2. If I were to keep going, I'm going to keep mine going as fractions. I prefer working with that. So if I do 4 times 4/5, I would get 4/5, and then multiply that by a fifth, I would get 4/25. For C, write an equation. So it's going to start a sub n is equal to the first term, which would be 20, because it says it starts with the 0 term. And then we are multiplying by a fifth to the n minus 1. Alright, 21 says each of the following tables shows an exponential relationship. How could you recognize that it is exponential? So I put a note in there. We know something's exponential when we multiply by a consistent constant. The general form of our equation is up top here, so it's y is equal to a times b to the x power. B is what we're multiplying by every time. A is when x is 0, it's what y is. I'm not going to write a word problem for each one because you could pick lots of different things and your answers can vary. If I'm going to check if these are exponential, I'd be looking for, do I multiply by a constant? So 100 to 300, I'd multiply by 3. Yep, I'm good. I'm multiplying by 3 each time. So if I'm going to write an equation, I get y is equal to, well, there's my a value. I start with 100. Multiplying by 3 each time to the power of x. For the second one, I'm getting smaller. So if I'm thinking, how do I get from 1600 to 400? I am multiplying by a fourth. So I have y is equal to 1600 times 1/4 to the power of x. So 22 says write an equation to model the amount of money in a bank account if you start with $500 and earn 3.8% interest each year. So keyword here is you are earning interest every single year. So we know this has to be a form of exponential growth because we are making money, we are earning interest. So general format for that is y is equal to a times 1 plus r. Remember, we're earning that interest, so we're adding it on to the power of t. R is the rate, so here that's 3.8%, but we want that as a decimal, so it'd be 0.038. And then it's just a general equation, so we don't have to put anything for time. A is the only other thing we need to know. That's our starting value, 500. So my equation would be y is equal to 500 times 1 plus 0.038 to the power of t. If you like to simplify in the parentheses, you can. So I get y is equal to 500 times 1.038 to the power of t. Okay, next one says write an equation to model the value of a car if its if it costs $18,500 when new and loses 20% of its value each year. So if you don't know that, as soon as you buy a new car and drive it off the lot, it immediately depreciates in value, which means it loses value because it's no longer considered brand new. So cars definitely lose value. So that's a form of exponential decay because we are losing money on it. So equation looks similar to exponential growth, but it's going to be minus the r because we're losing money on it. So here the r is 20%. We want it as a decimal, so 0.2. A is 18,500. That's how much I paid for it originally. So I'd have y is equal to 18,500 times 1 minus 0.2 to the power of t. Can simplify the parentheses, so I get 18,500 times 0.8 to the power of t. And then, I could plug in any number for t from here and see what my car is worth after 1 or 2 or 5 or 10 years. Okay, for each square root function, state its domain and sketch its graph. You can see I didn't put graphs on here. It's pretty hard for me to graph on my iPad, but we've been practicing graphing in class. So if you have questions, please, please, please ask during class time. I'm happy to help you. Let's just focus on domain. Remember, with square roots, we're taking the square root of a number, and so we can't take the square root of negatives because it doesn't exist. It's not a real thing. That's why it's important for us to focus on having the domain be only positive. So we take what's under the square root. So here it's just x. Set it greater than or equal to 0. And then if we need to solve for x, we do. So for a, this is the domain. X is greater than or equal to 0. So when I graph it and I make a table, for example, I'm only using values that are greater than 0. Same for this one. I'm only focused on what's under the square root. The only thing under my square root is that x, so again, x is greater than or equal to 0. For c, I have an x minus 4 under the square root, so I set that greater than or equal to 0. I do have to solve for x here, so I get x is greater than or equal to 4. So if I were to make a table to graph for that one, I'd only be using x values greater than 4. Thanks for watching!